Thanks, Oliver, again, and good afternoon, everybody, or good morning for some of you. As Oliver mentioned, we're going to cover WINCAPS 3 101 best practices. Going to kind of show you some of the techniques to use with WINCAPS, and also we're going to cover how to make a basic program. Kind of a prerequisite. You can either have gone through our factory basic program, or maybe today might be an opportunity for you, for those guys that like to learn on their own, to get started with the project. Today, we're going to learn about the 10 basic WINCAPS techniques, review a couple important terms. Also, I wanted to let you know that you can register and download a free trial version. Oh, that says trail of WINCAPS 3 at the following website. But I also I encourage you to, we're going to have this presentation available for you down the road, a recorded version. At the same time, if you see something, take a picture of it and you can immediately go to the link. So with that, let's get started. Let's review a couple different move types. There's the linear move, joint move, arc move, and spline move. The linear move, this is what the command looks like, move L. It's a continuous path move. Probably one of the most popular one is a point-to-point move and our joint move. It looks like this. This is your command syntax right there. Move P, go to position variable 10 to find out where your position is that you want to move to. We have arc moves, which allows you to take a continuous path and actually to go through 2 points to create an arc. We have a spline move. It's actually called a move S. And again, this is something you might use for a dispensing application or polishing or something like that, where you want a continuous speed. And you just, what you do is you use the set spline point to create multiple points, 10, 15, 20, 30 points, and then have the robot continuously move through those points to give you a nice, smooth move. We also have an assortment of logic statements and or is a very popular logic statement. You look at this one here, we're talking about in the program, if IO 14 is on and IO 6 is on, then we're going to run our start weld subroutine. So make sure you're aware of our logic statements. I'm going to show you a little bit later where you can find some of this. Let's touch on global and local variables. Inside WINCAPS 3, you have the option to use local variables or global variables. This might be a review for some people, but typically a global variable is something that is can be used by all sorts of different programs. 1, 2, and 3 programs can all access the global variables. If you're going to use local variables, then only that particular program can use that local variable. Program 1, Program 2, Program 3. And here's an example of a couple different global variables. Integers, floats, vectors, positions. That's the difference between global and local variables. TSRs, you'll probably use TSRs in your program too. And the easy way to see that in your program statements is they're actually called TSRs. These are typically supervisory tasks. They allow you to do non-stopping tasks, maybe run your e-stops in the background, or if you want to start a program, you'd probably use a TSR. This is typically, you'll see this is a very simple basic TSR program. Once the motors are on, we're going to run the depalletize underscore parts program. Very simple TSR. All right, let's get into some techniques. Particularly what we find out is, or what we see is, it's a good idea to keep when you're developing your program is to put your customer's application in there, who your customer is, what the application might be, possibly a start date. This is started March 25th of 20. And then most importantly is to keep your rev levels straight. Typically you're writing a program over the days, or maybe multiple people might be working on the program. So it's always kind of nice to keep track of your revisions. Also, if you have a revision that didn't work well, maybe you can go back a revision and get back to the starting point. So keep track of your revisions. Just a good technique to start out with. This is very important. I run into this all the first time programmers. WINCAPS 3, like most robot programming, does not program like a PLC. Robot programs typically execute sequentially. They don't have a fixed scan time like a PLC. You'll notice that it'll just, when we run through a program, it will run down sequentially top to bottom. So if you're putting an IO point there, you could be in some kind of trap. We know if you're a PLC programming, you have a fixed scan rate, maybe 40 milliseconds, 60 milliseconds. Every 40, 60 milliseconds, you're updating the IO. So just keep that in the back when you start to write your program, that you've got to consider things sequentially. Technique number 3. This is very, very nice feature built into WINCAPS 3. You can actually get started. Most of the pick and place applications, probably 60 to 75% of applications and robots are very typically pick and place. So what I'm going to show you real quick, let's jump over to WINCAPS 3. So we've already started our new project. We're ready to go. We're ready to get started, do a quick program. We're going to do a pick and place program. Come down here to program template. Actually, I'm going to cover this in just a little bit. So I'm going to come back to this actually. Now you know what I want. Sorry. Excuse me for a second. Program template. Ask you to select a pick and place program. Right here, it's kind of showing you a quick example of what a typical pick and place might look like. We're going to store our pick position in P0, our place position in P1. These are going to be our approach lengths, 50 millimeters. Obviously, you can change these. Okay, going to call program 1, finish. Let's teach it the pick place. Okay, that's where we're going to pick up from. Let's go to P variable 0. Get that position. Going to ask me where, okay, that's when I want to record it. Now we're going to place it, we're going to put it in our place. Move the robot. Let's get that position. Okay. Okay. So what I did right here is I did a quick grammar check, make sure everything's okay in the program, go through simulation. Double speed this thing up. It's at 10% right now. Let's run our simulation. There we are in under about 3 minutes. We've done a simple pick and place program, picking up and placing. Now you can actually see an example how the program is actually sequentially going through. See what's going on. This is automatically generated by WINCAPS 3. So you see in there, you can actually add some IO. So within 3 minutes, we've actually got a very basic pick and place program working. Stop the simulation. So I encourage you, here's how we do this right underneath project, program template, pick and place. We also have options for palletizing. You want to do a simple palletizing program. And we actually have easy vision if you want to incorporate some vision into your project. So I encourage you, start your project here with a program template. Another great technique to start with is to comment out the beginning of your program to give a brief description of what's going on. You'll notice here we have a little apostrophe in the very front of this. Whenever you put this little apostrophe here and start typing, it turns to a green text. And this is completely ignored by the program. And what it does is it allows you to comment out for the next person, for the next guy. Maybe if you're doing this program over a couple of days, kind of reminds you what's going on. But this is a great example how you begin to, the beginning of your program, start commenting it out. Another great feature within WINCAPS 3, and this is also on the Teach Panda 2, when you get started, start labeling all your IO. Then, if you're going to go to monitor it, you'll see a column called Smart. Click on that Smart, and then once you do a Smart View, once you click on Smart View, what it does is consolidate all the inputs or variables that you want to keep track of. You'll notice right here what I'm doing is I've jumped from 14 to 23. So now I have all the important IO that I'm looking for right in one place. So remember using Smart View is a great tool to help you troubleshoot when you're starting to write your program. Here's another good technique. When you're ready to get started to write your program from scratch, you're thinking about it, create all your robot movement steps first with comments. For example, on line 8, what I did was comment out on startup, go to the home position, move to P0. Then what I might start doing is actually writing my syntax and writing my program right after this. Go to this step, this step. So what it does is allows you, while you're thinking of the movements, you don't have to worry about the syntax and what's going on with your program. You've got the concept of what you want to do, and then begin writing your program after you write out your comments. It's a great technique, simple, basic. Another great technique is to consider sectioning off your position variables or your P variables. What we've learned over the past is sometimes once you get on site and you start to play around with the robot, everything's there, some things you didn't think about. If you've sequentially used your P variables or your position variables, you might run out of space, and then next thing you're doing, you're jumping all over the place with your addresses. So our suggestion is to maybe designate certain areas, maybe for your pick areas. P0 might be always your home position. P10 is always loading where the robot picks up, P10 to P99. P100 starts, it's always where you do your unloading. So what you're doing is you're structuring out your memory. It's a great thing with DENSO Robots is, unlike a lot of other vendors that charge you for extra memories for position variables, we give you opportunities to use thousands and thousands of P variables. So don't hesitate to drop back and make these use different addresses for different parts of your application. And as a matter of fact, in some companies, they actually specify where they want position area variables in the program, so their maintenance guys know to go to P100 is always unloading and P10 is always loading. So some customers actually specify that. So figure out where, kind of think about that a little bit ahead of time. Subroutines are also a great tool, very easy to do. If you'll see in this little quick subroutine, what we're doing is we're establishing grippers, the gripper valves. We called it subroutine open grip _1. That's a double solenoid, so we're resetting or turning off one, then we're setting the other solenoid, then we're delaying in this variable here. We got a 100 millisecond delay in there, and then we end subroutine. So essentially, and then we hit end sub. So anytime I want to use this, close my gripper, open my gripper, I just call this open grip 1, and that's it. It's one line in the program. Very, very nice tool. Registered strings. It's also a nice tool. You can actually speed up your programming, and it actually helps you eliminate syntax errors. Let's jump back into WINCAPS 3 just to give you an idea. All right, here I am back in my program, and I want to start inserting some commands. So just double click where you want to put the command, right click, insert registered string. These are various commands that I put in here. So all I do, if I want to add a delay of 100 milliseconds, double click, and it inserts that command. Do another one, right click, insert registered string. Now I'm going to do a move P0. It's a very, very nice tool to help you. What you can do is start copying and paste these into your inserted strings. And then as you develop your program, you don't have to worry about syntax errors. Now, there's also a way you can actually create your registered string. You go underneath the project tab, the command builder, choose the command you want, insert the command, highlight the new command, right click, register the string, pick the string address. All right. And sorry. Here's your command builder right here. These are all your various commands inside of WINCAPS 3. Let's talk about robot control. Say you want to add an accelerate accel to my registered string. Come up here and click on this, insert this command into the editor. And you can see it's actually inserted it into my program. Control C. Excuse me. Oops. Back in there. Oh, I'm sorry.
What's his name?
Oh, and got added in there. So that's how you actually register a string in there. Remember to click on this, insert this command, and you can continue to build up your registered string list. It's a great tool. And then always remember, I quite a few people I get started with actually forget that we actually have a simulator built into WINCAPS 3. So essentially what you want to do once you're done, you think done writing your program, check your syntax grammar. Here's a little highlight that button, click on that. It's going to check your grammar. It's going to point out any mistakes you might have in your program and you can fix those mistakes. It actually tells you at the line item where to fix it. And then you can also simulate your project, hit this, and then you're actually going to hit this button right here, and then you're in run mode. Run your simulation. To give you an idea, that's what a typical simulation looks like. You can actually take this simulation, and on the far right-hand screen of WINCAPS 3, you'll see a movie, and you can actually export this out as a movie, ship it to your customer, ship it to somebody else in your facility. We do it quite a few times. We'll do a lot of simulations for our customers and just ship the movie or simulation movie to the customer. It's a great tool. A lot of our robot competitors or other guys that are in this business actually charge you thousands of dollars to have the simulation. We actually have it built into WINCAPS 3. So let's just quickly review. So when you're naming your project, include the customer, the application, data creation, and most importantly, the revision. Number two, WINCAPS 3 does not program like a PLC. They execute sequentially. There is no fixed scan time like a PLC. I really encourage you to use a program template if you're going to do a palletizing or a simple pick and place, or if you want to incorporate some vision in your application. It's right there, very easy to do, under 3 minutes, and you got a very basic program. Comment out the beginning of your program. That's definitely going to be benefit you and your customer or anybody else that has to maintain the machine later on. Label all your I/O when you get started, and click your Smart View when you're number 6 when you're getting started from scratch. Create the robot movement steps first with your comments, and then build your program after those comments. Consider sectioning off your P variables. Use subroutines where applicable. Use inserted registered string where possible. It speeds up programming. And save your project. Check your syntax grammar and simulate your project. So that's pretty much all I have today. Thank you very much for joining us. As I mentioned earlier, these webinars will be made available if you'd like to download them online. If you got any questions, you can reach me directly. With that, I'm going to turn it over to Oliver, and Oliver is going to review some of the questions that might have come up. Thank you.
Awesome. Thank you, Ted. All right, guys, thanks for joining. We're going to review some of these questions right here. Let's see. If you have any more questions, go ahead and put them in the Q&A section below. So Peter asks, looks like a great tool. How much are the yearly update costs and the cost to get the latest version? For WINCAPS, it's a one-time fee. So if there are any upgrades during the releases for that particular WINCAPS, like for WINCAPS 1, 2, and 3, then we're going to give you that upgrade for free or update for free. Let's see. Santibanez, I think. I'm sorry, I'm butchering your name. This program worked with 2-axis robots. We don't have any 2-axis robots, but Carlos stated that you can use our smart controller MC8 to make your own program for 2-axis. So this MC8, yeah, also uses WINCAPS. All right, Dave asks, how many robot programs can the controller hold? Do you need to purchase any memory upgrades? So typically 1 controller per robot arm. And also for some of our Scara robots, you can have 1 controller with a dual arm control. But you don't need any memory upgrades. And sorry, we do have, scrolling. We have some high spec controllers, but it is for specific functions only. I think he's asking how many programs can the controller hold. Depending on the memory, I believe we can hold thousands of programs in our controller. Ted, do you know that answer off the top of your head?
I'm sorry, could you repeat that?
The number of programs our controller can hold.
No, I don't know that number. Brian, are you there, Carlos?
I think we can hold quite a bit. I think programs are very small in memory size. Which robot models does WINCAPS come with? Is it per robot pricing? No, there is no price difference. WINCAPS is sold separately when a robot is purchased. So once you have WINCAPS on your laptop, you can connect it to any robot. So if you have one number of robots, you can connect WINCAPS to each robot. And you also have offline programming as well. You have offline programming robot library to create projects, and you don't have virtual arm. Yeah. Mark asked, can you copy and paste in and out of WINCAPS from a text editor? So yes, if you are on, let's just say Notepad, for example, or any other programming language, you can copy and paste the program into your WINCAPS Pro program. Mark asked, what cameras can be used with this version? Table from Excel. So, what cameras can be used with with Vision? Any Vision, pretty much any Vision camera can be used with our controller. We just need to get communication with their Vision camera and set those variables for the XYZ, rotation X or YZ, and send it to our robot. Let's see here, is there any up here? Point data. Oh, Dave asked point table from Excel. So yes, we can export point data to CSV file and copy and paste it into an Excel file. So if you guys need any data for the robot points, we're able to export that. Other questions in here? I think those are all the questions so far. Oh, here, Mark asked, when programming, is the language sensitive to the number of spaces used or tab characters? No. So if you have a space or a tab, those aren't going to add time, I guess, if that's what you're asking, to the robot. What's it called? The robot cycle time. If you do have spaces or tabs, it's also not going to. It's not sensitive to reading the program language. So if you have an extra space on accident, I don't think it's gonna. It shouldn't have any effect. Let's see. So far, that is all the questions. All right. So if you guys have any other questions, please go ahead and post them in the Q&A. I'm going to leave this chat open for the next 10 minutes. Also, we're going to follow up with you in an email, and we're going to send you this PowerPoint presentation as well as a link to the webinar that we had just now. And you guys can go over it as you need on your own time. So thank you again for coming, and thank you, Mark, for or Ted for presenting today.
Well, thank you, Oliver. Appreciate it very much. And yes, thanks everybody. Take care and have a great day.
All right. Thanks, guys.
Bye-bye.